Hello guys, I'm Alukosha. Welcome to another tutorial session of Python programming. And in today's class, I'll teach you guys how to write a Python script to determine if a given random variable x is a prime number or not. Second, the program will also help to compute and determine the numbers of factors and print the factors, okay, of the user inputs. Okay, guys, let's quickly take a look at the script and explore. Okay, so just go to run. Okay, and see how it works. Okay, now to enter a number, so you enter any random variable. Okay, so just let me go for 21 and enter key. So prime number is false, that is 21 is not a prime number. Factors altogether, okay, and the list of factors are 1, 3, 7 and 21. Okay, then the program will also ask you to input another number to verify if it's a prime number or not. So let me go for 31. Okay, prime number true, meaning that 31 is a prime number, and okay, number of factors in 31 we have 2 altogether, and list of factors are 1 and 31. Okay, let me just go ahead and let's try one more. Let's go for 119. Okay, 119. Okay, prime number false. Okay, numbers of factors we have 4, and list of factors we have 1, 7, 17, 119. Okay, finally let me just go for 911. Sorry about that. Okay, what? 911 is actually a prime number. That is great. Okay, so 911 is a prime number, and yeah, the prime number is true, and number of factors 2, and list of factors we have 1911. So I think that's pretty cool, guys. Okay, do you care to create a cool app like this? Let's get started with Python programming. So what I'm going to do now, I'm going to actually develop this from the scratch. To do that, let me just go ahead and kill this program. Okay, and also let me go ahead and create from new, and this, let me take it photo. Okay guys, I'm going to develop this script from the scratch. Okay, let's go ahead and just write a comment. Okay, so to write comment, you just use hashtag on program to determine if a random variable. Okay, I actually want random variable x, but you can actually use any letter, any English letter you choose. Okay, so Python program to determine if a random variable is a prime. Okay, a prime or not. I think it's better like that. Yeah. Then second, we also want to compute the factors, okay, of the user input, and okay, so let's just say then sorry about that, compute the factors, okay, of the user input. Okay, the user input will actually be taken as a random variable. Do you understand? Because we don't actually know what is in the mind of the user. So invariably the user input is actually a random variable. So that's it. So I think that's a good one. Sorry, this is not English class, so never mind. You can just give me a better how would I put it, like a better is it title? Yeah, it's just like a title of my program. So I just like this, like designing. And what are you doing? Yeah, I just like to do this like here's so kids sometimes. So it's pretty cool. This is not a creative art. Anyway, that is the that is the title of my program. Let's get started. Okay, yeah. Now before we get started, it's better for us to get ourselves acquainted with what prime number is all about, and then let's also discuss something about factors of number. So let's do like 2 minutes maths. Okay, but it's just going to be a primary maths. Okay, so yeah, let's get started with this. Generally, you can divide numbers into two, can I say, broad group, okay, two major classes, okay, or two major classes, okay. So we have the odd numbers, okay, and the even numbers. I think my KS2 students are pretty cool with this, right? So everybody should know odd numbers and even numbers. But this is not where we are going actually, because I will actually talk about prime numbers and factors. Okay, so now odd numbers can be divided into two, and also even number into two. So we can have the prime numbers. I'll just target P, and the composite numbers, that is C. So even numbers also divided into prime number and composite numbers. Okay, so now let's quickly talk about prime numbers. Prime numbers are generally positive integers with only two factors. So that is number divisible by itself and 1. Okay, so let me take that again. Prime numbers are generally positive integers with only two factors, two by itself and 1. Okay, so the key word there is such that prime number has only two factors, so 1 and itself. Okay, for example, let's take 13 for example. So we have the only number that can go in 13, we have 1, then 13. So you can see that 1 is factor of all numbers, okay. Another thing is that you should know that prime number is a positive integer, okay. What about 14? 14, if you pick up your calculator, 1 can divide 14 without remainder, then 2 will go in 14 without remainder. This is not funny. I think the next number should be 7 without remainder, then 14. Okay, so in this case now we have more than two factors. So we have 1, 2, 3. This is 7 actually. So we have 1, 2, 3, 4. So anytime you have more than two factors, so that's no longer a prime number, and that is what is known as composite numbers. So what are composite numbers? So composite numbers are numbers with 3 or more factors, while prime number is exactly 2. So divisible by itself and 1. Composite number are what? 3 or more factors. Okay, so that's pretty cool. And you know how to get to factors. To determine factors of a number, just go ahead and divide that number by a given number. Okay, let's say by counter, like 1, 2, 3, 4 counting numbers. And if there is no remainder, then it means there's a factor. For example, I have 7. No, don't let me take 7. Let's take I'm sorry about that. Let's just take 6. Okay, so and I have this counting number 1, 2, 3, 4, 5. Then the number itself 6. So we know that 6 and 1 are factors of 6, because we know that factors of a number are 1 and itself. That one is not negotiable, okay. So 1 and itself. Then the other numbers now, 6 divided by 2 will give you 3, so no remainder, okay. That is going to give you can we call it whole number, okay. This by itself whole number, so better say no remainder too. So 3 divided by 6, no remainder, so you can take this. So these two are factors. Now, but if you go ahead and do 6 divided by 4, there will be remainder. So 4 is not a factor of 6. If you go ahead and do 6 divided by 5, there will be remainder. So 5 is not a factor of 6. So the factors of 6 will now be what? 1, 2, 3, and 6. So the beautiful thing about factors of number is that the number itself and 1 are always factors. Then you can have any other number. So for this very one, we have more than 2. So this is a composite number. This is a composite number. Unlike if you have something like 3. So and you have this divisor, 1 will go in 3 without remainder, 2 there will be a remainder, so it's going to give you a float, so 2 will not be then 3. So for this one, this is a prime number, so 3 is a prime number, 6 is a composite number. That's pretty cool. So let's get started. Okay, yeah. Having said that, now guys, I'm going to define two methods. So the first method will be for prime, and the second method will be for factors. Okay, so what are methods? Methods are actually user-defined function. Let me just put it that way. User-defined function. Okay, so better say function that are associated with the given class. Okay, so now let's go ahead. The first method I'm going to define, I'm going to target prime. So to define the method, just use define like definition def. Okay, define the method, and I'm going to target prime. So that's function. Then I'm going to pass an instance. Okay. So sorry about using programming terms. So I don't want to be going to what instance or something about it. So or an object, better still. Let's say a placeholder. Okay, so this just pass this x, a variable x. Okay, so now for this very tutorial, the random variable is uppercase x, because in statistics we normally use uppercase x. Okay, to delimit a random variable. Yeah, that's all. I've defined my method. So anytime you define a method like that, we just use column like that and enter key. Okay, so now the condition is prime. I want the number to be a prime number, so that is prime. So is prime equals to true. So this is the only condition whereby it will be true. Then any other um, statements, okay, argument will be false. Okay, so now just keep that there. Now, if that's the first condition now, if the random variable x, okay, is less than 2, don't forget that any number less than 2, and since we know that prime number are actually positive integer, so the only number you can consider is 1. So 1 is not a prime number. Why? Because 1 did not have up to 2 factors, just 1 and 1. So that's only one factor. So the least, or let's say the least prime number is actually 2. So therefore it shouldn't be less than 2. So that's why the random variable should not be less than 2. So if random variable is less than 2, then its prime will be false. So is prime equals false. So that's the first condition for it not to be true. Don't forget that its prime is true, and it's only true if it is true. So if the number input, the user number, okay, the user input is less than 2, then it is false. That's first one. Okay. Second, anytime you use this if conditional statement, use column, don't forget. Okay, so that one is over. Okay, so else, say else should be under this. Don't forget your identification, maintain proper identification. Else, okay, since I use else now, you have to use column again, then enter key. So else, what is going on now? I want to define range of number, because don't forget that yeah, let me just quickly call your attention to something again. Sorry about that. Now I have let's say the user input is 10. So I need to test all prime number. Okay, 1. So 1 is a factor, that's 4. Then 2 is a prime number. Okay, 3 is a prime number. Now you have to go ahead and divide all this. 10 divided by 2. If the remainder is whole number, then you take it. That is, there is no remainder. That's the implication. So that's the implication. Because if the whole number is, if the remainder is whole number, that is, if the whole number is 0 and the remainder is 0, then you take it. Okay, so that's the implication. So let's go ahead and do that now. So that's what I want to do now. So else now. So let's go ahead and define range of number. For I in range. For I in range, I know that 2 is going to be part. Okay, so 2. Then you count till you get to the user input, which is random variable x. Okay, so that's what we have there. So I is a counter. You can actually use any letter in English alphabet if you like. You can do for A in range, for B in range, for, but conventionally, quite good numbers of programmers like to use I. So I will also go with I. Okay, not I or you. Okay, sorry about that. Just to play for. Okay, so if I in range is so what should happen now? Since this is yeah, for I, so you have to use column. Okay, so then enter key. Now let's go ahead and do the division now. I'm going to do something like this. I is a counter. Don't forget, I'm going to increase by 1 later, but the next statement is one institution whereby if I divide the user input by 2, it should return what like whole number 0. Okay, then there shouldn't be remainder. So that's what I want to do now. So now, if you want to return the remainder, we don't use I can say specifically that we actually use backward slash for division, but I don't want to. I'm not doing division this time around. I want a remainder. So for remainder, you use percentage. So we call it modulo in programming, or wildcard. Okay, so modulo anyway. So now, if random variable that is user defined input x, like when you divide it by the counter I, then the answer should be equals to 0. That is, there shouldn't be a remainder, or it will return whole number. That's the indication. So that's what I have there. So for that, then prime number will be true. But if that is not the case, it's false. Is prime equals false. Okay, so that is pretty good. Okay, so now since I want to maintain equal spacing between my lines of code, so let's just go ahead and apply break. So break is just to that's what this break is, just to maintain, like you want to maintain equal spacing. Okay, like in your Word documents. Okay, so yeah, that's pretty cool. Then you can go ahead and return. Return should come under else, so make sure that you maintain your proper indentation. So return is prime. Okay, that's pretty cool. So pretty cool. You need not to put space in between these. It's not going to affect your code anyway, but if you don't mind it, I can just put like that. So yeah, that's the yeah. Yeah, that's the method for how to determine. I'm not yet through. There's something I still need to do because I need to work with this counter. So I want a situation whereby you have 2, 3, 4, 5. So I'll be adding 1, 1, 1. So yeah, but I'm going to include that one in the next method. So let's define the second method. So now this time around, I want to determine a new function, and I'm going to target factors. So and take this argument x. If you like, call it distance. Okay, so this is just easy. So don't forget, when you define the method, you use what column. Sorry about that. Such as to maintain proper indentation. So this time around now, I want to quickly go ahead and do what I need to do now. So I'm going to define 2 objects. The first object will target fact, and the second one that will be a fact list. Because that will be a list. Okay, a list of number. So I can have 2, 3, 4, just to keep the number will be used to divide the user inputs and see if it returns the whole number or not, or if the remainder is 0 or not. So that's that. Okay, so those are the 2 objects. So equals to, so fact now 2 objects, and the second will be a list of number. Okay, so that a list. So to define a list, you use is this square bracket? You use square bracket to define a list. And don't forget that 1 is factor of all number. Okay, like if you have a given number now, that number itself are 1 are factors. For example, if I have 4, 4 and 1 are factor of 4. If I have 20, 1 and 20 are factors. If I have 100, 1 and 100 are factors. So now is not the second is another case entirely if it has to be a composite number or a prime number. If it has to be a prime number, then it will be 1 and itself. But it will be a composite number, then there will be other numbers in between. Okay, so now, so I created a list already with this square, also assign 1. I'm still going to assign itself, that is x, so but just let's put it there. So that's the first one, because 1 is a factor of all integer, so that's why I have 1 in the list. So then I will go ahead and populate the list with time. So let's go ahead and define a range now. So for a counter I, okay, in range. Okay, so go ahead and open this now. Range, that's the function 2, and the user defined variable x. That is the random variable, uppercase. Okay, that's it. So use colon and that. Now, what I want to do now, if not, what I want to do now, just look at this code now. So if not, you have the random variable. Don't forget your, is it white card or you call it a modulo? Anyway, you like divided by counter I. Now, what I'm going to do now is this. I want the counter, this fact, like the counter is such that the very first one you have 2, then it will add 1 to it, then 3, add 1 to it, 4, add 1 to it. Now, as I'm adding 1 to it, then I'll also test such that I will use it to divide. I'll do the user input divided by the new number, then I check if there is the remainder. That is, if the remainder is whole number or not. So that's what I want to do now. Okay, so now, so fact, so to add 1, you are adding 1 to the number, so you are plus, okay, equals to 1, that is plus 1. So that's the line of code for that. Okay, so let me quickly explain something here now. Now I have fact here. Now this line of code, this very one, okay, we add 1 to 2, so the new number will be 3. Then use 3, do x divided by 3, the random variable divided by 3, and see if it returns, if the remainder is whole number or not. Then this will run again. Then the next number, this 3 will change to 4, then you divide, change to 5, then divide, change to 6, just like I explained earlier on. So let's say if the user input was to be 10, then you do 10 divided by 2, then you do 10 divided by 3, 10 divided by 4, 10 divided by 5. So and you also check also if the remainder, this gives remainder, percentage give remainder. So if the remainder, that is I, if the remainder is whole number or not. So that what that is for. So if the remainder were to be whole number, then it's going to add it to the list. So for example, let me check. Let me quickly explain this. I have 10 here now. So now 10 divided by 2. Okay, so it's whole number. The remainder is whole number, so it will add it to the list. 10 divided by 3 is not whole number. It will not add it to the list. 10 divided by 4 is not whole number. It will not add it to the list. That is the remainder. 10 divided by 5. The remainder is, there is no remainder, that is, the remainder is 0, which is, and that is whole number. It will add it to the list. So it will add 2, it will add 5, then it will add 10 to the list. So that's what we are trying to do there. Okay, so now, and that's what I want to do now. So I'm going to append to the list. So to append to the list I now, so you now have fact dot list. No, sorry, fact list. This is list. Okay, so it's list. This one is list. So I want to populate the list now. Sorry about that. So fact list dot append, because I want to populate this list. We are not creating a new list, so I'm just modifying it by adding new number to it to the end. So then you add, what do you add? Append the new I. So the only condition for you to add a counter is if it returns, if the remainder is a whole number. So for example, 10 divided by 2, there is no remainder, so the remainder is 0, and 0 is whole number, so it will add to the list. 10 divided by 3, so the remainder is not 0 because there is a remainder, so it will not add to the list. So that what it is line of code. Okay, so it add new factor to the end. Okay, at the end of the stuff. So that's what we have there. Then finally, also another thing is, apart from 1 is factor of all number, then the number itself is factor of itself. For example, if I have 10, 1 and 10 are factor, so I need to append what? I need to append the stuff too. So fact list again, then dot append the user input. So that is the random variable. So for example, if the user input, if the number given by the user is 10, then it's going to append 10 also at the end. So it's going to populate, the population starts from the first element in the list will be 1, then it will run through this, then append, then the last element will be the user defined variable. Okay, so that's what we have there. So that's pretty cool, right? So then finally we can go ahead and return it. Sorry about that. Then return. So that should be under return. Yeah, so you just return this. Where is it? Return this, guys. Fact and fact list. So return as a function. So return fact, comma, fact list. So I think that should be pretty cool, guys. So now find definitely we have the variable already. The random variable is x. So I'm going to object x, create object x. It's a placeholder, okay? So and it should be an integer, don't forget, not a float, because we are dealing with factors and prime numbers, and they are integers, okay? They are not floats. Okay, so you need to sanitize it. So answer this to sanitize, make sure that the user input is an integer. So the user cannot give you 2.1. If the user gives you 2.1, that will be error. So that this is sanitizer. Make sure that it's an integer. So you can only take integer from the user or counting number. Okay. So yeah. Then function to take value from the user and use input. That's the function. Input. Then you can just give me a number or something like that. But I will write type something like enter any number. So since it's a random variable, so that's any number. So enter any number. So I'm taking a random variable, enter any number. Okay. Yeah. So that will take the number. Another thing is that if you want to use double quote, this is a string, okay, because it's text. So you quote it. So it's a string, you call it string, okay? So you can close the stuff now. So this will close the input, then you have to close so that way. So this for input, the second will be for the integer. That will be beautiful. So this line of code should take information from the user, prompt the user to give stuff. Then next, I can go ahead and print a prime number because I have defined prime number here and you have everything just fine. So go ahead and print it. So print. English is gonna be quiet. Don't let me print something. So prime number. Okay, it's a prime, prime number. So just a prime number. So prime number is pretty cool. Let me just put it like that. Prime number. Okay, so what is the prime number now? So comma prime. The user input. So if it has to be a prime, then it should tell you yeah, the prime number is prime. If not, then it should tell you it's prime false. Yeah. Because this prime is a function, so that's why you have to close this here and you close this there. You understand what is going on? Close. So that's that. Okay, so next let's go ahead and print the numbers of factors. Maybe there are two. For example, for 3, I have 1 and 3, so it's going to print 2, then it will then list. So but now let's first print the number of factors before listing. Okay, so go ahead and print number of factors. You can put double or single quote, but this time around let me just work with single quote so that you can see that you can use it alternatively. So if you like, you can use double or single quote. So print number of factors, numbers of factors are, or yeah, let's just say something like that. So that's beautiful. So that should give us number of factors. So now we have to take the number of factors now. So we have factors x because we have it in factors x. So you have to take it. So comma factors x. So it's going to that will be the output. So it's going to output that. Okay. Then also output the list. That is, but it's a counter this time around. Okay. So it's going to output how many are there altogether. So that's pretty good. Then finally, let's also list the factors we have in the user defined. Okay, how many? So we list them, maybe 1 2 3 and 6 for 6 if the user input to be 6. So now let's go ahead and print list of factors now, right? Yeah, let's use single quote here also. List of factors are list of factors are, so you can put space also. So now let's take it now. So we have the list already. So we have factors x, then and this list that will be populated. You know, you have the fact 2 and the one that will be populated, something like that. Okay, so now we have factors, the random variable, right, and the list. Don't forget that the list is not just one because you append here, so you keep populating the list. So that's what we have here. So that's just as you represented it. So you can go ahead and close it. Okay, we have okay. And before you can run it, you have to save it first anyway. But let me save it as let me just call it. I don't know. What should I tag this thing? Python program to determine. That would be too long. Let me just prime and factors determinants. This is not like determinant in mathematics. Sorry about that. Okay, so yeah, I think it's pretty good. Now this is fact list. So I think the spelling is, sorry about that. So you have to be careful. Just make sure that fact list. Okay, so everything should be cool. So I will run and let's just go ahead and complete it without wasting. If I run this code, let me quickly go through everything and make sure that everything is okay. Okay, so there's a mistake here. There shouldn't be anything here. Okay, now second, I'm through with the script for the program though, and the only thing is that you are to run this, it will not prompt the user to input of second time or third time, and I want the situation whereby it's going to be like a it will always prompt the user to keep it will always asks for user input every time as often as possible. So mean that I need to stage. Okay, so enter any number. Let's go for a composite number 15. Good. So 15 is not a prime number, so prime number first. Number of factors in 15, we have 4 altogether. And list of factors are 1, 3, 5, and 15. So, but I can't do it again. I have to close this and run it again. So let me run it again. This time around, I will put a prime number. Let me just go with a prime number 911. I don't know if 911 is a prime number. Interesting. 911 is a prime number. Yeah, sorry about that. Okay, so yeah, prime number true, number of factors are 2, and list of numbers are 1 and 9. Okay, so I want a solution whereby I can keep it can keep asking the user for yeah, for something. Okay, so now this time around I'm going to then impute the prime number like a second break, just like a time lapse, something like that. So in that case, I need a Python module. So import time. So I need time. Then second, I'll need to define class main class. So now there is not a problem though, but since I'm defining main now, so I need to work on my indentation. Work on this. Let's work on indentation first. So let's meditate. So bring this one up and bring it down. Okay. So then I think what I'm going to do, I think it will be a tab. But let me confirm first. I think a tab should do. So just a tab. Yeah, a tab should do for all. So just tab for each one. Just single tab. Just back and tab. I think that should work. So because of forever could not. Okay, so that's why I'm doing this now. Or else we'll not be able to run the program. It will not be a forever kind of yeah, script. So but I want it to be in forever block. Okay, so just a tab should do. Okay, so all this should go for tab 1, tab, tab, tab. Then I can end it now. So I can close the loop now, main loop, main, and enter. Then main. Okay, I think everything should be pretty cool now. Okay, so let's go ahead and run. Yay, please don't give me run. Yay, yippee. Okay, so that's pretty cool. I think everything will be pretty cool. So let me go for 119. I don't know what that's. Prime number first, number of factors 4, list of factors are 1, 7, 17, 119. Let me go back to let's just use 2. 2 is a prime number, right? So prime number true, number of factors 2, list of factors 1 and 2. So let's go for a very big number 1, 1, 1, 1, 1, 1, 1. Yeah, now how many ones? 1, 2, 3, 4, 5, 6, 7. So I wouldn't know. Okay, so prime pause, number of factors 4, list of factors 1, 2, 3, 9. This is pretty cool. Can you see now? Let's just go for any number 10, 10, 10, binary number to see how powerful this app will be. Yeah, prime number first. Yeah, it's taking time. Wow, meaning that this is going to my laptop will not collapse because there will be quite the number of prime number here is going to be endless for us. Why did I do this? I'm very sorry. Please, what are the factors? This is going to crash my system if I'm not careful. Wow, what? Why did I type this? I'm sorry about this. I think I need to kill this system because I didn't think about the number of factors it's going to give, and you see this thing automatically hang up. So I think I need to kill it because this is going to be crazy factors. Okay, so let me just kill it and I'll go ahead and run. Sorry about that. I can be naughty sometimes. See how my stuff is shaking. Kill it. Thank you. So let me run again. I will not do that again. So let me just run this for the last time. But I want to go for that number 10101001. I think this is not too many. This is not a bad one. I think you should be able to run this for me. Yeah, 32. So meaning that the first one would have been crazy. Yeah, 32. That one could have been like. So list of factors are 1, 2, 5, 10, 17. Guys, no human can do this. This is nothing else than. This is AI, guy. Go ahead and develop your own AI, artificial intelligence, okay? Because I'm not sure anybody can do this, guys. See, 2, 1, 2, 1, 2, 1, 2 on prime number first, 36 factors, and within a second, guys, this is just too much, guys. Go ahead and subscribe to my channel. Guys, do have a great day ahead. See you. Do have a great day ahead. Bye. guys. Let me end with 911. Okay, so bye guys. Have a good day. Bye.
Wake the streets up. Yeah, yeah. Okay. Wake the streets up. Okay. Come on. Okay. Wake the streets.